2026 AIME problems number 7. Find the number of function pi. Pi is the symbol of the function. Mapping the set 1, 2, 3, 4, 5, 6 onto the set A itself, such that for every element in the set A, when you apply the function for 6 times, it comes back to itself. So we'll prove pi 1, pi 2, pi 3, pi 4, pi 5, pi 6 are all distinct. So therefore, in this case, the function pi 1 all the way to pi 6 will be just a permutation of the 1 through 6. So this is a very important part of it. Otherwise, probably you're going to do different value mapping to the same value. That will be more complicated. So we can prove it. If for any value a and b in different elements in the set, a and b from 1 to 6 can be, for example, 1 and a 2 for this one. If the function pi map a and a b to the same value, and then we're going to apply 6 times, that's still the same value. But given this pi apply 6 times to map itself, and then we can figure out the b also have the same feature, we'll get a equal to b. That's a contradiction to a does not equal to b. From here we get a equal to b. So it is contradiction. We just complete the proof. That means for the previous one, we said the pi 1 all the way to pi 6, they are all different. Okay, for different value map from the function pi, we'll get the different result. So we just denote this pi apply 6 times, I'm going to put a pi 6, because that means pi 6 times. I'm going to pi a equal to 8. So the function pi cycle on the subset 1, 2, 3, 4, 5, and 6 can be 6. Okay, the cycle. Can see you can do this example: 1 map to 3, 3 map to 4, 4 map to 2, 2 map to 5, 5 map to 6, and 6 map to 1. So eventually 1 just map to itself. We can start with the 2, 2 map to 5, 5 map to 6, 6 map to 1, 1 map to 3, 3 map to 4, 4 map to 2. So eventually come back to 2 for 6 mapping. So that means this is the cycle 6. Okay, just coming back to itself after every single element is visited. So it can also be the factor of 6. The factor of 6 can be 1 and then 2 or 3. Cycle 1, cycle 2, or cycle 3. I'm going to give you an example here. For this one, I'm going to put a 1, 2, and a 4 in one group. 3, 5, 6 in the other group. These 3 value cycle on itself. For example, 1 map to 4, 4 map to 2, 2 map to 1. If you want to do 6 mapping, so you're gonna another round, you still come back to 1 itself. 2 will be the same thing. So 3 in this cycle, 3 to 6, 6 to 5, 5 to 3, and then continue another round. You're going to get a pi to the 6 mapping will be itself. So this is going to be the cycle 3. We can do the same thing, cycle 2 and cycle 1. Cycle 1, for example, you just, the cycle 2, that's going to be easy. 1 map to 2 map to 1, something like that. Okay. And then cycle 1 just the map to itself, right? And pi 1 equal to 1, pi 2 equal to 2, those kind of cycle 1. So when you map to itself 1 time, so only after 6 times, it still map to itself. This is just the 2 examples, cycle 6, 2 cycle 3, and we may have any other cases. We're going to list them in a moment. We have 8 different cycles. Cycle 6, That's just one cycle 6 we already have in the previous example. Okay, this one. And also we have two cycles of 3. And now we have one cycle 3, one cycle 2, and one cycle 1. Number of elements will be 6. So 3 on one cycle, 2 others in one cycle. And then one left over will be the cycle mapping to itself. And the next one going to be 3, 1, 1, 1. One cycle 3, 3 cycles of 1. And then with the cycle 3, we have these 3 cases. And then we do cycle 2, 3 cycles of 2, and then 2 cycle 2, and 2 cycle of 1. 1 cycle 2, and then 4 cycle 1. And then 6 cycles of 1. So we get the only possible 8 cases for the different cycles. So we're going to do one at a time. For the cycle 6, the arrangement is going to be 1 to 6 will be 5 factorial because it's a circular arrangement. 6 factorial over 6, 5 factorial. That's 120. Well, 2 cycles of 3, the number of ways of choosing 3 numbers for the first cycle will be 6 to 3. To arrange them, the number of ways to do it will be a circular arrangement. That will be 3 factorial over 3, that will be 2 factorial. The number of ways choosing the 3 numbers for the second cycle will be 3 choose 3, that's 1. The number of arrangement for these 3 elements will be also 3 factorials divided by 3, you get a 2 factorial. So that means we get the total number of possibilities will be 6 choose 3 times 2 factorial, 3 choose 3 times 2 factorial. But 1, 2, 4, and then 3, 5, 4, 6 is the same as 3, 5, 6, and 1, 2, 4. That means I choose this earlier we're gonna get the order, but the order doesn't matter for these 3 element set, another 3 sets of elements, that will be the same. So that means we need to divide by 2 factorial for the 2 sets arrangement. And then you get a 40. So third case, we get a 1 cycle of 3, 1 cycle of 2, and a 1 cycle of 1, like this. For example, I'm going to put a 1, 2, 4 in a cycle, 3, 5 as a cycle, and then 6 by itself. And we do the same thing, we're going to get the total. For the first one, you're going to 6 choose 3 for the number. The arrangement, 3 factorial divided by 3. And then you get the remaining 3, I'm going to choose 2 for the second group. So 3 choose 2, and also doing the arrangement, 2 factorial over 2. And then this one, there's only 1 left over. So we get the result 120. They are not going to be repeating and interchangeable for these 3 groups. The next one, 1 cycle of 3, 3 cycle of 1. So the total you can see we can do 6 choose 3 for the elements of 3, and then this is going to be the arrangement. And then you're going to remaining 3 number, I choose 1 for the second group, second cycle. But this is only one way to do it. Still have 2 left over. We're going to choose 1 for the third group. 2 choose 1. The last one, only 1 left over. Because this 1, 1, 1, this is going to be group, no difference. The order, for example, I'm going to choose 1, 2, 3, and 2, 3, 1, 3, 1, 2, they are all the same. So different arrangement for the different groups will be treating as the same. So they're going to be repeated. They repeated 3 factorial times. So you're going to divide that one, you're going to unique grouping for this cycle 3, and then 3 cycles of 1. You got a 40. The next one going to be 3 cycle of 2. And then the total we're going to do similarly. 6 choose 2 for the 2 elements. The arrangement going to 2 factorial divided by 2. For the remaining 4 elements, you're going to choose 2 for the second group of a cycle. And the arrangement also going to be 2 factorial over 2. The leftover 2 will be the last group. the arrangement will be the same. Because these 2, 2, 2, I can do 1, 2, 3, 4, 5, 6 will be the same as 3, 4, 1, 2, 5, 6, the same as 5, 6, 1, 2, 3, 4. So the arrangement of the order of the group will be repeated 3 factorial times. I'm going to divide by that. You get a unique grouping for 3 cycles of 2. By calculating, you get a 15. The next one going to be 2 cycle of 2s and a 2 cycle of 1. We get the result 6 use 2 for this first cycle, and the arrangement going to be 2 factorial over 2 for the cyclic arrangement. The remaining 4 I'm going to choose 2 for the second cycle, the same arrangement. Still have 2 number left over, I'm going to choose 1 for the third cycle, and then the last group only 1 number left. Since this one repeating for 2 and 2, you divide by 2 factorial. For this 1 and 1 repeating, you're going to divide by 2 factorial as well. By this calculation, we get a 45. So this will be the value for the 2 cycle of 2 and a 2 cycle of 1. And the next one going to be 1 cycle of 2, 4 cycle of 1. So we're going to do 6 choose 2 for the elements of 2, cycle 2, and an arrangement of cyclic arrangement will be 2 factorial over 2. These are the 4 elements left. These are 3 elements left. These are 2 elements left. These are the last element left. So you get this number if we consider the order. But these are 4 group of cyclic cycle of 1. They will be repeated 4 factorial time. You're going to divide that. You get a unique grouping. You get a 15. We still have 1 more case left. That will be 6 cycles of 1. So each one mapping to itself. 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6 to 6. This one will be easy. That's only one way to do it. So we get the total number of ways, add them up. You get a 396 ways for the cyclic, for the cycles. So the answer is 396. We get the answer then.